Right, year 10. It's, what is it, Wednesday evening. You've got your lesson tomorrow, so this will be released sometime tonight and hopefully in time for your lesson tomorrow. Sorry about the shadow across. I haven't sorted out the lighting in this room, but anyway, let's have a look. This question is, so, name Dr. Norton. Look, it's a quiz. That's fun. Zinc sulfate can be made in two methods. The equations for these two methods are that's zinc sulfate, that's zinc sulfate. Calculate the percentage atom economy for making zinc sulfate in method 1. So this. So what you do is you circle the zinc sulfate and then you circle all of the products. Give your answer to 3 sig figs. Relative formula masses, so you don't have to work out the MRs. They're given to you. Don't need that. Don't need that. You can use that. And H2O is 18. That's how I'd do it. So this is 161, and then the whole egg is 161 and 18. So it's going to be 161 divided by 161 plus 18, and then times by 100. 161 divided by 161 plus 18, close brackets, times 100. 89.9%, 89.9, 3 sig figs, done. Alright. Mark scheme, I don't know, would probably say 3 sig figs. You don't do that, you've lost a mark. I haven't got the mark scheme. I am the mark scheme. I'm not bothered about your actual mark. I'm just bothered that you're correcting it as you go. If you get that, 89.9 to 3 sig figs, you've got 3. For every 1 mistake that you make, knock a mark off. Method 1 gives a higher percentage yield. Highest percentage atom economy for making zinc sulfate than method 2. Give a reason why it's important to use a reaction with high atom economy. High atom economy means less waste products formed. So look, the waste product here is water. The waste products are water and carbon dioxide. They are wasted because that is your desired, and these are just wasted. So atom economy makes fewer waste products. Sample of copper nitride. Just looking at this, copper Cu, nitride is just N. Right, so you go Cu, N. It's an empirical formula. Sorry, should have said that straight away. So straight away I'm into empirical formula mode. 3.81, 0.28. Divide by the what they're given. That's to speed you up in the exam, and they do that. So I'm going to divide by that, divide by that. Hopefully you spotted that and you're just on it. 3 over 50, 0.06. It's going to be a ratio. I can spot this one already, but anyway, I'll do it. 0.02. This ratio is not that useful, so we need to simplify the ratio by dividing both sides by the smallest number. That means you'll get 1 of these to 3 of these, a 3-to-1 ratio, Cu3n. That's the empirical formula. You must show your working to get full marks. Cu3n. Something is telling me I do need to get the mark scheme up just in case I make a mistake, so I'll get it up on my computer shortly, but I need to turn my computer on. So anyway, I made a mistake there, sorry, but that looks right to me. Compound, again, spotting straight away, it's empirical formula. 28% sodium, boron and oxygen. Boron, the least interesting element on the periodic table. Little joke. 21.8. 55.4 oxygen. You know, so I practice what I preach. This is what I do. It's what I told you to do. It's what I do in the exam. Okay, let's get our raw ratio out. Well, that's about 1, isn't it? So 0.991, 21.8 divided by 11, 1.98. About 2, 55.4 divided by 16, 3.46. Alright, let's divide by the smallest number. Okay, so that's going to be 1. 1.98 divided by 0.991 equals 2. 1.997 is 2. And then 3.46 divided by 0.991 equals 3.49. Okay, so 3.5. It's not there yet. 2 to 4 to 7. Na2 B4O7. So that was a bit more complicated. It took a while for the actual answer to come out, but it did in the end. Just getting the mark scheme up now, folks, so bear with me. What did I call it? Triple calc quiz with mark scheme. That is question number 3. Yay, 2 to 4 to 7. And the previous ones. Question 3 was. Question 2, sorry. Cu3n. Brill. Alright. Relative formula mass of magnesium chloride. Okay, there are some easy ones in there. 24 and 2 chlorines plus 35.5 plus 35.5, 71, 81, 91, 95. Alright, so good done it for 2 marks. So there will be some lovely questions on your GCSEs. A student wanted to make 11 grams of copper chloride. That's copper chloride. The equation is calculate the mass of copper carbonate you need to make that much copper chloride. Right, again, practice what you preach, Norton. Write out the equation again. Right, they want to make 11 grams of this. How much of this? So you go down, across, and up. There's our target. Mass of copper carbonate that reacts with hydrochloric acid. Okay, ratio 1 to 1. Divide by the MR of this times by the MR of that. CuCl2, that's 63.5 plus 35.5 plus 35.5. CuCO3 is 63.5 plus carbon, which is 12, plus 16, 16, 16, which is 48. I'm going to work out those MRs first. 63.5 plus 35.5 plus 35.5. Oops. 35.5. 134.5. It's worth a mark in the exam, that, so make it stand out, because you might muck up something else later. 63.5 plus 12 plus 48. 123.5. Okay, that's the MR. That's the MR. I'm communicating here to my examiner. Let them know what I'm doing, alright? Just in case I make a mistake later on. So, I'm all ready to go now. 11 divided by 134.5 equals 0.08178 moles of that. 1 to 1, 0.08178 moles of copper carbonate are needed, and now all I've got to do is times that number by 123.5. 10 grams, 10.100, 10, what does it ask me for sig figs? 10.1, I'm going to do 0.1 because that's reported to 0.1, so 10.1 grams. Okay, that's the answer. So let's just have a little look, check that I've got that right, which I have. Cool, you get a mark for the MR of this, you get a mark for the MR of this, you get a mark for the moles, and you get a mark for the right answer. The percentage yield was 79.1. Calculate the mass of copper chloride they actually produced. So we've got to assume, therefore, that they were doing this, they were aiming for 11, but they actually only made 79.1% of that. So you do 11 times 0.791. All right. So 11 times 0.791. Or, another way of doing it is 11 divided by 100, which gives you 1%, and then you times it by 79.1, but that's the same. So I'll do 11 times 0.791. So they only made 8.7 grams, 8.701, so that's going to be 8.7 grams, 8.70, whatever. 1 mark for the working, either this or this, and 1 mark for the correct answer. Look at the equations for the 2 reactions for making CuCl2. It's very similar to the first question, this. You can see straight away that the top reaction has got a lower atom economy because it makes more waste products. Battery might be dead on my phone here, hang on. Battery's on 5%, that's not good. That's better, it's charging. Right, calculate the percentage atom economy for reaction 2, alright? That's what we're trying to make, and that's everything. So H2O is 18, CuCl2 is 134.5, so 134.5 divided by the whole egg, which is 134.5 plus 18. It's basically is the same as the first question. 134.5 divided by brackets 134.5 plus 18 close brackets times 100 because percentage atom economy. Oh, messed it up. 134.5 divided by brackets 134.5 plus 18 close brackets equals times 100 equals 88.19%. 88.197. What did I do up here? It's all like 1 decimal place there, so I'm going to go 18.8.2. I'm going to write that in, put that in brackets like that. What do they ask for? Let's have a look. That's my I Am Looking at the Mark Scheme song. 88.2. 1 vote free. The atom economy for reaction 1 is lower. Compare the atom economies. The atom economy for reaction 1 is lower because it's making more waste products. Or you could be more specific and say because as well as water as a waste product, you're also making carbon dioxide as a waste product. So that's what that's about. Again, this idea of waste products. Right, a bit more modern this question. Magnesium reacts with steam to produce hydrogen gas and magnesium oxide. So they might often show you a little diagram of an experiment and you have to just get your head around it. Not that difficult to understand. There's a glass tube, they're going to push steam in, pass it over the magnesium, and the unreacted steam and some hydrogen will come out. So you're going to produce hydrogen. Classic experiment this. It often breaks the glass tube, it gets so hot. A teacher demonstrated the reaction to the class. The figure below shows the apparatus. The equation for the reaction is magnesium plus steam. Notice gas there, that tells you that it's steam and not just liquid water. It makes magnesium oxide, so the magnesium goes white and you make hydrogen gas. The teacher used 1 gram of magnesium. Use the equation to calculate the maximum mass of magnesium oxide produced. Alright, Mg plus H2O makes MgO plus H2. Use 1 gram of magnesium, 1.00 gram, and they want the maximum mass of magnesium oxide, which is here. Give your answer to 3 sig figs, and they're giving you the relative atomic masses, so we go down, across and up. Down, divide by 24, reaction ratio 1 to 1, one of these makes one of these, and you times by the MR, which is 24 plus 16, 40. Very easy now. 1 divided by 24 equals 1 over 24. Thanks, calculator. 4, 1, 7, 0.0417. Wait a minute, I'm trying to show off here. Moles, then just times that by 40. Don't need to do any ratio. 5 over 3. 1.67 grams, 1.67. 3 sig figs, 167. Happy with that? I'm happy with that. Right, let's just check. 1.67 grams. Correct answer to 3 significant figures gains 3 marks. If the answer is incorrect, allow 2 marks for the following. If you've got 24 and 40, you can get 2 marks. Okay. If you got an incorrect answer at the end. The teacher's demonstration produced 1.5. Right, so you're expecting 1.67, but you only got 1.5. So the percentage yield is 1.50 divided by 1.67 times 100. 1.5 divided by 1.67 equals times 100. 89.8. 89.8%. Again, just feel like I need to check it, but even though I know it's right. What question are you on? 6. 89.8. If you got a wrong answer here and you've used their answer, the answer apparently is 82.4. Give the reason why the percentage yield is less than 100. So why didn't the teacher make quite as much as they wanted to make? Well, could have been a load of things. Most likely for me is magnesium not all reacted. You've got this spiral of magnesium. The outside of the magnesium reacts easily. When you do this experiment, you see lots of it doesn't react. The reaction might be reversible. Your magnesium might not have been pure, so you've weighed it thinking it's pure magnesium, but it might have impurities. When you've tried to weigh it, this would be a problem. When you tried to weigh it, you couldn't get it all out of the tube. That's another way. So when you scraped it all out to put on the weighing scales, you've lost some there. That's the best one though. Magnesium not all reacted. A company uses chlorine. Chlorine is Cl2. I know that because chlorine is in group 7 and it goes round. It's diatomic. See, I'm using my chemistry. To produce titanium chloride from titanium dioxide. What is the relative formula mass of titanium dioxide? Oh, I am kind giving you this, aren't I? That's 48 plus 16 plus 16. 48 plus 32. 48 plus 32. 40, 50, 60, 70, 80. Okay. The charges come out again. I haven't got that on the mark scheme, where are you? Yep, 80. The company calculates that 500 grams of titanium dioxide should produce 1.2 kilograms of titanium chloride. The company. However, the company finds that 500 grams of titanium dioxide only produces 900 grams. So you were meant to produce this, but you only produce this. 900 divided by 1200 times 100. 9 over 12. Hope you can all spot that. 9 divided by 12 or 9 divided by 1200 equals times 100. 75%. There are harder percentage yield questions out there. I just haven't given you them. Right, another reactant masses one. Disguised as some sort of practical. Question A and B are practical based. All right, they're missing. You see, we start on question C because I'm just doing the calc. So there are practical questions here. Weigh 5 grams, 0.5 grams of iodine. Dissolve the iodine in ethanol. Add an excess of zinc. Adding an excess of zinc ensures that all of the iodine reacts. Stir the mixture, filter off the excess zinc, evaporate off the ethanol. Anyway, calculate the minimum mass of zinc that's needed to be added to 0.5 grams of iodine so the iodine fully reacts. Alright, I'm not going to write it out again because I've got space here. Got 0.5 grams of this. Calculate the minimum mass of zinc. Alright, so the iodine fully reacts. Okay, divide by the MR. Times by the MR. It's another 1-to-1 ratio. Sorry for making it boring. I didn't give you any good ratios really. 0.5 divided by the MR of iodine, which is I2. So that's 127 times 2. 127 plus 127. Watch out for that. I bet I caught a few of you out. 254. So you're going to divide by 254. Then you're going to times by 65. Alright. Bet that got some of you, didn't it? 0.5 divided by 254. 1.968. 969, whatever, 1.969 moles. Oh, times 10 to the minus 3. Whoops. Not very well written there. Sorry, everybody. Do it neater in the exam. Same here. 1.969 times 10. 1.969 times 10 to the minus 3. And then I'm going to times by 65. That's the wrong number. 65. 0.127. 0.128. 0.128. Right. Sig figs. Don't seem to be bothered about sig figs there. 0.128. Let's check that. Question 8. 0.128 grams. 1 mark for. What's it giving you marks for here? 1 mark for 0.5 divided by 254, and 1 mark for timesing by 65. So they're not going to give you a mark for dividing anything by 127. So 1 mark for doing this bit right, and 1 mark for doing this bit right, even if this number was incorrect. Okay. A different scientist makes zinc iodide by the same method. The scientist obtains 12.5 grams of zinc iodide, and the percentage yield was 92. So he got 12.5, and that was a 92% yield. So 100% yield would be bigger than 12.5. So you've got to use these two numbers to work out what it would have been. So we know that 12.5 grams is 92%. The way I would do this, 12.5 grams, I would divide it by 92. Because 12.5 is 92%, so if I divide by 92, that gives me 1%, and then I times it by 100. Alright? That's how I would do it. Because I know that's going to give me a big number. Dividing by one number and timesing by a bigger number will definitely increase. 12.5 divided by 92 equals times 100. 13.59. So everything here is the 3 sig figs, so I'm going to do 13.6 grams, and I'll put a box around that for the examiner. Another way of doing it, I suppose, is to go, you could do it like a formula. I'm just overcomplicating this. Percentage yield 92, and we know that that equals the yield that you got, which is 12.5, divided by the max yield. So we can rearrange this. Max times both sides by max. You get 12.5 equals 92 times max, or times x. And then you divide by 92 and you end up with this. Times 100 in there as well. I didn't explain that very well. I'm tired, but anyway, that's how. Blah, blah, blah. Right, suggest one reason why the percentage yield is not 100%. Okay, the reaction could be reversible. There could be unreacted zinc. No, actually, unreacted iodine, because they used an excess of zinc. Unreacted iodine. They're good enough. The reaction did not go to completion is a really good one to go for. Right, question 9. Iron pyrites. It's made of iron and sulfur, therefore it's ionic, and it's also a lattice. Right, these are irons, these are sulfurs. Determine the formula. You don't just count them up. Ionic substances have an empirical formula. In other words, the simplest ratio. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's Fe9 there, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. S18. The simplest is FeS2. Alright. Fe9S18 gets you 0 marks. The formula for an ionic compound is the simplest ratio. An equation for the reaction to make nickel is another one. See, this is showing you how few of them have got difficult ratios, but some of them have. Alright, but just none of the ones are given you. Anyway, it's an atom economy one. Calculate the percentage atom economy for the reaction to produce nickel. So that's my desired, and that's all of them. That's my yolk, that's my egg. This is going to be 59, and the whole thing is going to be carbon and an oxygen is 12 and a 16. Alright, so I've got everything in there. I don't use this. Some people use these, but I don't bother. The egg works well. 59 divided by 59 plus 12 plus 16 times 100. 59 divided by 59 plus 12 plus 16, close brackets, equals, I'm getting tired, 67.8, 3 sig figs, 67.8, yeah. Cool. I think I've got 4 marks. Yeah, the answer is 67.8. No, get your sig figs wrong. So it's gone blurry, hasn't it? Sorry, has that been blurry all the way? I'm really sorry if that's been blurry all the way. And it's not your eyes. It's me and my phone. 67.8. Got to make that point stand out there because it looked like 678. You don't want that. Yay, a ratio. A ratio. It's a ratio. A ratio Nelson. That was Admiral Nelson's first name. Horatio, by the way. That was a little joke. It's a ratio. Right, 10G. Right, initial reaction 40 kilograms. Kilograms, we don't do it in kilograms. 20 kilograms of sodium. You can do it in kilograms. It'll give you the same answer if you keep everything in kilograms. So, anyway, TiCl4 plus 4Na make Ti plus 4NaCl. I've got 40 kilograms of titanium chloride. 40 kilograms. That is 40, I'll do it, 40,000. It doesn't make any difference. I don't want to explain. I'll explain why in a bit, but I'm going to do it in grams because I told you to do it in grams. Alright, explain why the titanium chloride is the limiting reactant. So all I've got to do is prove that that's the limiting reactant. They've even told me. So, with limiting reactant questions, you go down, down, pause, and then work out which is limiting. Alright, divide by 23. You see how having it to thousands doesn't make any difference. You're still going to work out the same ratio. 20,000 to 40,000 is the same ratio as 20 to 40. So actually, I'm going to do it. I'm going to make my numbers easier because you're allowed. All right. So, or do I just stick to it? Yeah. I don't know, I'm stuck between two stools. I would just, to work out the limiting reactant, you can do it in kilograms or grams. Right, I'm going to do it in kilograms, but if you're doing it in grams, whatever, you'll just get more awkward numbers. Titanium chloride is going to be 48 plus 35.5 plus 35.5 plus 35.5 times 4. Alright, I'm going to work that out before I do anything. 48 plus 35.5 times 4, 190. Okay, I think I'm set up now to work out moles of this and moles of this, and I'm going to tell the examiner I'm working out moles. Actually, if I am working out moles, it's got to be in grams, hasn't it? I'm going back to, sorry guys, I'm going back to, because if I want to write moles and moles here, I'm going to write grams. I know I'm annoying. 40,000. But I am doing it for the first time ever, this question, so this is what it'll look like in an exam, just a bit neater. Moles. 210.5 moles. 20,000 divided by 23 equals, just checking there, no big numbers, folks. 20,000 divided by 23 equals 869.6. So just to show you, if you did 20 divided by 23, 20 divided by 23, you'd get 0.869. You'd get just a more handy number, I suppose, but you couldn't write the word moles after it. So I'm doing this. So I've worked out moles of that and moles of that. I'm pretty sure I've just got these marks. So why is this the limiting reactance? So you've got to try and show that to the examiner that you know why this is the limiting reactance. So I'll do this. I'll do it this way around. If you had 869.6, you need, it's a 1 to 4 ratio. So if you've got 4 of these, you need 1 of these. So if you've got 869.6, you need 869.6 divided by 4. I'm going to do that calculation. See what I did in my calculator there? 869.6 divided by 4. So I'm going to write this. To react 869.6 grams of sodium, you need 869.6 divided by 4 grams of TiCl, which equals 217.4 grams. Alright, let's have a look. You haven't got enough. But you've only got 210.5 grams. Therefore, limiting. And I know I've gone off the side here, but don't care. I've smashed that question. Alright, you can do it the other way around. If you've got 210.5, you need 210.5 times 4 of sodium. You need 842. Whereas you've got 869.6, meaning you've got an excess of sodium, which makes titanium chloride the limiting reactant. But that's how you answer that question. I don't quite know if you get how you get 4 marks, but you have to have made that really clear. In other words, you need the number 217.4 in there, or whatever this was, 842. For stage 2 of whatever this was, the percentage yield was 92.3. The theoretical maximum mass was 13.5 and the yield was 92.3. Alright, so that means that they've got, what was the actual mass? Well, if you take the actual mass, I'll try and do this one better next time, divided by the max mass, and then you times it by 100, that equals 92.3. The theoretical maximum mass was 13.5. So I'm going to call actual mass X divided by 13.5 times 100 equals 92.3. Right, get rid of this times 100 by dividing both sides by 100. And then let's get rid of this 13.5 by timesing both sides by 13.5. So X equals 92.3 over 100 times 13.5. That was me doing maths better. I hope the mathematicians amongst you appreciate that. 92.3 divided by 100 equals times 13.5. 12.46. Let me just check my answer now. The maximum was this and the actual was lower. That looks good to me. 12.46. See how all of these are to 1 decimal place and 3 sig figs? I'm just going to report that as 12.5 kilograms. Yay! Right, I'm going to write you all a message. Cheers, everyone. Have a great half term with your families. See you later.